So what we're going to talk today about is how to calculate the equivalent resistance of a bunch of resistors that are hooked up either in series, as is shown here, where the current flows through one after the other, or in parallel, where the current splits up, as is shown in the picture on the right, and part of it goes through one resistor and part of it goes through another resistor. So let's quickly talk through the resistors in series and the resistors in parallel. All the slides for these are available in a handout. I strongly encourage you to go, if you don't have the handout, pause this, stop it, go back, download the handout, and use it as you go through the slide. It'll save you drawing a whole bunch of pictures. Okay, so what's a series connection? A series connection has a single path from the battery through each of the resistors and then back to the battery. And the important thing is that between the resistors, so if I look at the circuit there on the left, I've got resistor 1, resistor 2, and resistor 3. There's nowhere else that the current can go. Any current that goes through resistor 1 has to go through resistor 2 and then has to go back through resistor 3 to the battery. So there's no junctions at all. So in that case, the current through each of the resistors is the same. And so what I want to do, the net goal, is to take that system and replace it with a single resistor that's equivalent to the 3 resistors in total. So how can I calculate it? Well, I know that if I look at the circuit on the left, the one with the 3 resistors, the voltage across the battery has to be equal to the total of the voltage drop across each of the 3 resistors. I can't create energy from nowhere. So V for the battery is equal to V1 plus V2 plus V3. And we know from Ohm's law that the voltage across each resistor is I times R. So the voltage on resistor 1 is just going to be I times R1. The voltage on resistor 2 is going to be I times R2. The voltage on resistor 3 is I times R3. And the I is the same for all of them. On the circuit, the simplified circuit, where I just have one equivalent resistance, I know the voltage on the battery is equal to I times R equivalent. So if I set these two equal to each other, because the voltage on the battery is the same in each of the equivalent circuits, what I get is that I times R1 plus I times R2 plus I times R3 is equal to I times R equivalent. And since it's an equivalent circuit, the current flowing through it is the same. So if I divide both sides by I, what I get is that the equivalent resistance is just equal to the sum of the resistances. So for resistors hooked up in series, the voltages are different, the current is the same, and the equivalent resistance is just the sum of the resistances. What if I hook them up in parallel? Well, in a parallel circuit, there's junctions, so you can see it drawn here at point A and point B. At junction A, the current I coming from the battery splits up, and part of it goes through each of the 3 resistors, and then at point B, those 3 currents join back together, and the current I flows back out of point B into the battery. Okay, so what I know now is that whatever current I have going into point A, that current I splits up into 3 parts, and the sum of those 3 currents, I1 plus I2 plus I3, has to be equal to what came in. What comes in has to be equal to what goes out. So if I rewrite Ohm's law, so I know V equals I times R, I is going to be equal to V over R. Okay, so if I look at this equation, I say, okay, well, I is just going to be equal to V over R equivalent. I1 is going to be equal to the voltage across resistor 1 divided by R1. I2 is going to be the voltage across resistor 2 divided by R2. And I3 is going to be the voltage across resistor 3 divided by R3. But what are these 3 voltages? Well, if I look back at my picture, you can see that that battery is hooked up between point A and point B. So the voltage across resistor 1 has to be equal to just the voltage on the battery. Same thing for resistor 2 and for resistor 3. So for batteries, so for resistors hooked up in parallel, the voltage across each resistor is the same, but the currents are different. those are good concepts to remember. So for series and parallel, what's the same, voltage or current? Make sure you know those for a test. That's a good concept question to come up from. All right, so if I look at my equation here, the sum of the currents is equal to the current out of the battery. So if the voltages are all the same, I can just divide through by V, and then I get the equation that's there in orange at the bottom. 1 over R equivalent equals 1 over R1 plus 1 over R2 plus 1 over R3, or in other words, the equivalent resistance is equal to, I have to add up the inverses, so 1 over R1 plus 1 over R2 plus 1 over R3, and then take the inverse to get the resistance back again. So what I want to do now is I want to go through a bunch of examples where I find the equivalent resistance for circuits, and then I'll have you guys do the same thing. So how do we start off? Well, if I've got a complicated circuit, what I do is I start off, I look for an obvious group of resistors that's either in series or in parallel. I calculate what the equivalent resistance is for that group. Then I redraw that circuit, replacing that combination with a single resistor. And then I look again to see if there's an obvious series or parallel group, and just keep on simplifying it until I'm down to only one resistor, which is my equivalent or my total resistance. So let's go through and do some examples. So we'll start off with just a few resistors and we'll work our way up. So if I look at this circuit here, I've got two 12-ohm resistors and one 6-ohm resistor. So R1 is a 6-ohm resistor. Is that in series with RA? Well, no, it's not, because the current coming through R1 splits up, and only part of it goes through RA. So it's only in series if the same current goes through both of them. How about with R4? No, same story. The current has split up. Only I2 is only part of I total. So what do I know? Well, I know that RA and R4, those ones are in parallel with each other, right? The current has split up at that junction here that I'm marking with red, splits up, I total splits into I1 plus I2, and then at the bottom junction they join up together, and I have I total going back out. So since they're in parallel, I add up the inverses, so 1 over RA4, and I'm going to name my new resistor with the subscripts of the two resistors that I'm combining. So I'm combining resistor A and resistor 4. So I'm going to call it RA4 because that tells me what it is. I can look back later at my work and figure out what I did. So 1 over RA4 is 1 over 12 plus 1 over 12. 1 over 12 plus 1 over 12 is 2 over 12, which is just 1 over 6. So RA4 is just going to be the inverse of 1 over 6, which is 6 over 1. Right, so RA4 is just 6 ohms. So now I'm going to redraw the circuit. I'm going to take the RA and R4, I'm going to replace them with just one single 6 ohm resistor. Okay, so if you look down below, I've taken out RA and R4, I've combined it, and it's just one 6 ohm resistor. So now I've got R1 of 6 ohms and RA4 of 6 ohms. How do those compare? Well, the current that flows through R1 turns the corner, flows back down through RA4 and back to my battery. So those two are in series. So if they're in series, my R total, which is going to be R1, A, and 4 combined together, it's going to just be the sum, R1 plus RA4, so 6 plus 6, which is equal to 12 ohms. So I can replace my circuit with a very simple picture of one 12-volt battery and one total resistance of 12 ohms. What's the total current flowing through the circuit? Well, once I've drawn my single resistor, I total is just going to be the voltage divided by the total resistance. So 12 volts over 12 ohms is 1 amp. So I know that I total is going to be the same coming out of the battery no matter which of my pictures I look at. So now what I do is if I want to know what's the voltage across resistor 1 or what's the current through resistor 4, I work my way back through the circuit. So let's do that. So if I look at my next more complicated circuit, so now I'm bound to two resistors. I know what my current is flowing through each of those resistors, and so I can calculate that the voltage across resistor 1 is going to be the current times R1. Current is 1, and I1 is 6 ohms. That should be an ohm symbol there. So 1 times 6 is 6 volts. So I've got 6 volts across this guy. And I can do the same thing for RA4. I could say that it's 6 ohms times 1 amp, or 6 volts. Or I could say that it's the total voltage on the battery, 12 volts, minus 6 volts. And I get 6 volts either way. Okay, so now I know I and V for resistor 1. And I know V for resistor A and for resistor 4. Okay, so I'm moving back up over to here. So now I've got to move back to my most complicated picture. I want to find what's the current 1 and what's current 2, because I know the current splits up, and part of it goes through resistor A and part of it goes through resistor 4. Well, what's the current through resistor A? Well, the current through resistor A, I know the voltage is 6 volts. I know the resistance is 12 ohms. So the current through A, which is I1, is going to be VA over RA, 6 over 12, or half an amp. And I4, the current through resistor 4, is going to be the voltage, which is 6 divided by 12, again, which is half an amp. And if I look, I can see, I can just check that IA plus I4, half plus a half is equal to 1, which is what I had coming from the battery. Okay, so by working my way from the most simple picture back to the most complicated, I can figure out the I and the V on each of the components in the circuit. Okay, let's add a resistor. So now I'm up to 4. All right, so what's an obvious combination here? Was all I've done in this picture is I've split up the resistor in that first vertical line into 2 bits. So what's here? Are those two guys in parallel with each other? No, they're not in parallel. They're only in parallel if the two ends are hooked together with nothing else in between. So if I look at R4 and R2, they have a resistor in between them. So those two guys are not in parallel. The only thing that we can do is R2 and R3 there. Those two guys are in series. If they're in series, I just add them together. So R23, so I'm going to put again the subscript 2 and subscript 3 to remind me what I'm doing. R23 is going to be just 8 plus 4, or 12 ohms. Then I'm going to draw my circuit. I'm going to replace those 2 resistors with a single resistor. Okay, so now I get to here. And this looks very familiar. This looks exactly like what I had in the previous one, right? So now I've got a 12 ohm and a 12 ohm. How are those related? Well, those are in parallel again. So parallel, I add the inverses. So 1 over 12 plus 1 over 12 is 1 over 6. So R234, so now I've got 3 subscripts to tell me that I'm adding those 3 resistors, is 6 ohms. So I redraw my circuit. Now I've got R1 and I've got R234. How are those related? Well, those are in series with each other. So if they're in series, they're just going to add up. And 6 plus 6 is 12. And so it's the same situation that I had in the previous slide. The total current is going to be 1 amp. 12 volts divided by 12 ohms gives me 1 amp. And I could work my way back through and find all the voltages and currents again. All right, so let's go and look at another one. So here, what do you see? So is R1 and R4, the top and the bottom, are those two guys in parallel? No, they're not in parallel. Why aren't they in parallel? Because I've got something other than wire in between them. All right, there's something other than wire in between them, so those two guys are not in parallel. Is R1 in series with R2? No, because the current splits up at that top junction and only part of the current. So the current isn't the same in R1 and R2. And so those guys are not in series with each other. The only thing that's obvious is that 2 and 3, those two guys are in parallel with each other. So I've got to add the inverses. So 1 over 8 plus 1 over 8 is 2 over 8. Then I flip that upside down, 8 over 2, which is 4 ohms. So R23 is 4 ohms. So you might have noticed a pattern here. On the previous slide, when I had a 12 and a 12 in parallel, I got 6, which is half of 12. Here I've got an 8 and an 8 in parallel, and my equivalent is 4, half of 8. And that's going to be the same whenever you have two equal resistors in parallel. Your equivalent resistance is just going to be half. All right, so now I'm going to redraw my circuit. I'm going to replace R2 and R3 with a single resistor, R23 of 4 ohms. So if I redraw it, that's what I get. And so now what's the relationship between R1, R23, and R4? Well, whatever current comes out of the battery just flows around. There's no junctions, nothing. So those guys must all be in series. So I'm just going to add them together. So R total is going to be R1 plus R23 plus R4, and that gives me 15 ohms. Okay, so now my equivalent circuit, I've got my 60-volt battery and a 15 ohm resistor. So the total current there is going to be 60 volts divided by 15 ohms. I is equal to V over R. I total is going to be V total over R total. So I get 4 amps flowing through the circuit, and then I could work my way back. I could figure out what's the voltage across each of these resistors and what current is flowing through each of these resistors. So here I know, for example, I've got 4 amps coming out of the battery. So 4 amps flows through R1 and R4. So 4 amps flows through R1 and R4. And I could calculate the voltage on each of them by using I times R. So voltage on resistor 1 is going to be 5 times 4. And on resistor 4 is going to be 6 times 4, 24 volts. Okay, and for R23, I'm going to split up the current that comes down. Part of that current is going to go through here. Part of it's going to go through there. I can figure out what the voltage is because I know that 60 volts if I look at my middle picture, 60 volts is across the battery. I'm going to lose 20 volts across resistor 1 and 24 across resistor 4. So 60 is going to be equal to 20 plus 24 plus whatever the voltage is on 2, 3. And so I can rearrange it and get that the voltage across resistor 2 and across resistor 3, they both have 16 volts across them from top to bottom. And then I can find the current by doing the 16 volts divided by the resistance of 8 ohms, and I get 2 amps. Okay, so work your way through it. Make sure you're able to do a problem like that. You might have to do something like that for the homework. All right, let's go even more complicated. All right, so what do we have? Are R1 and R5, are those two in parallel? No, they're not. Why not? There's something other than wire between the ends. How about R2 and R4? Are those guys in parallel? No, they're not. Why not? R3 is in between them. So what's the only relationship that we can see? Well, R3 and R4, those are in series with each other. So whatever current goes through resistor 3 goes around the bend, also goes through resistor 4. So the equivalent resistance R34 is just going to be 5 plus 15, which is 20 ohms. So I'm going to redraw that with R34 replacing resistor 3 and resistor 4. Now if I look at that, now I can see that R2 and R34, those guys are in parallel. So I add the inverses. So I've got one is 60 ohms, R2 is 60 ohms, the other one is 20 ohms. So now those are not equal. So 1 over 60 plus 1 over 20. So you can either add those in your calculator or you can do least common denominators. So that would be 1 over 60 plus 3 over 60 gives you 4 over 60. And remember, you have to take the inverse at the end. So that's 60 over 4 or 15 ohms. So now I'm going to redraw the circuit, replace R2 and R34 with a single. Now what's the relationship? Well, all of these guys are hooked up so the current flows through one after the other, all the same. So they're in series. So the total resistance is 25 plus 15 plus 20 or 16 ohms. So now I've got a 60 ohm equivalent resistance hooked up to a 120 volt battery. So what's the current going to be? The current's going to be 120 volts divided by 60 ohms. So I total is going to be 2 amps. And again, I can now work saying, okay, I know 2 amps flows through resistor 1, resistor 2, 3, 4, resistor 5, and work my way back and get the current and the voltages on each of the components. I'm not going to work through it, but I encourage you to go back, work through how the voltage and the current split up on all these components and make sure you can figure it out. Okay, so what do I want you to do? Well, I want you to do this problem. Here we've got 7 resistors. I want you to calculate what's the total resistance in this circuit. And also I encourage you, although I won't grade you on this, go back and work through and figure out what's the current through and the voltage across each resistor. So I want you to find the total resistance and I want you to find the total current. Those I will grade you on, and I encourage you to work back and try and figure out what's the current and voltage on each of the individual resistors.